simplifying radicals. Because let's say if you had something like square root of 2, you can't go any farther. You're done. What about if I said square root of, let's say 24? Well, we know it's not 5. It's close because square root of 25 is 5, but it's not there exactly. So we can simplify it. Now you can do ladders or trees. I'll show you both. Some of my students, they're just like, ooh, I want to do a ladder or a tree. I personally prefer ladders, and I'll show you why. Well, 24, if you break it down into common factors, maybe 6 and 4, 8 and 3, then, so there is 3 2s and a 3. Well, the way that I like to do it is ladders. Now, the only thing with ladders is you have to pull out prime numbers. 2, 3, 5 are the most common ones to get you going. I mean, sometimes 7's a factor, but most of the time, 2, 3, 5. So if you did 2 in no particular order, 12, 2, 6, 2, 3. And you didn't have to do all the 2s. It's just personal preference. But the reason why I did is because to simplify it, you are looking for a pair or 2 of a kind. Because, and I'll show you why, and then we'll just do the shortcut. Well, here we have, out of all 3, we've got square root, so 2 2s. Well, if I were to take the square root of 4 times the square root of 6, what do we know the square root of 4 is? 2. So square root of 24 is 2 square root of 6. Well, the way that I like to think of it, rather than having to write all this down, is, and you can do it either method, but just to show you on this one, a pair of 2s, so that means a 2 goes on the outside, and you multiply what's left. 2 times 3, 6. So that's the way I prefer doing it. But what you're actually doing is this. It's just a shortcut. All right, let's say square root of 72. Yep, now I'm going to do ladders just because I like ladders better. And just to show you don't have to start with 2, I'll do 3 this time. 8, 2, 2, 2. Now notice how this time you got a pair of 3s and a pair of 2s. So 2 times 3, 6, and the lonely 2 that's left over. What about if I gave you, let's say, square root of 60? 2 goes in there, 30, 2, 15, 5 and 3. So a pair of 2s, 15 left. 2 squared of 15. Now let's go back and do cube root of 72. Cube root of 72, you're looking for 3 of a kind. So, I'll use pencil. So if you're looking for 3 of a kind, notice how you've got 3 2s. So 2. And then you have 2 3s left over, 9. And we'll do one from scratch just so you can see it from there. Like if I said square root of, or cube root of 54 rather. 2 goes in there, 3 and 3. So cube root, so 3 of a kind, 3, 2 left over. Let's even say you had 4th root of, let's say, 80. Well, 2 goes in there, 2, 2, 2, then a 5. So 4th root, 4 2s, 5 left over. Now let's say that they put variables with there, because it's actually not bad. Let's say if I said square root of 8x cubed y to the 4th z. Well, first you do the numbers. So we got 8, 2 and 4, square root, so 2 of a kind, 2 left over. But then we have our variables. Well, remember there's an understood 2. 2 goes into 3 one time, 1 left over. So 1x, 1 left over. 2 goes into 4 2 times. 2 can't go into 1, so it stays behind. Let's say if I did cube root of we'll say 72 x squared y 5th z the 12th. Okay, so first take care of the 72. So do your little ladder. Remember, order doesn't matter as long as they're prime. So cube root, so 3 2s, 9 left over. And now take care of your variables. Can 3 go into 2? No. Stays behind. 3 goes into 5 once. 2 left over, because remember, literally we're doing this. 3 into 5 once. 2 left over. 3 into 12. 4. None left over. Hope this was of help to you. Have a great day.